Okay, so what we want to study now is what is in this slide, where we have two wires, both are carrying current, and we want to know the effect of one wire into the other. Now the force that one wire is going to exert on the other. But before we get into this, let me come back to this first slide just to remind ourselves again about the first hand rule. Okay, so what was this story? Suppose here we have the current going up. So what we do, we point our thumb going up, and then we encircle this wire with our four fingers, and as we are closing these four fingers, we'll get the direction of the field. So this is the field. Okay, what is important for us? I want to know what is the direction of the field at specific points. And in particular, I want to know what is the direction of the field to the right side of the wire. So what is the direction to the right of the wire, right at this point? It's going into the page. Do you see that? So we have this whole circle. Here it's coming to the right in front of the wire, and right at this point on the right side of the wire is going into the page. It's going into the page. So this is what we are denoting here. Then this magnetic field goes behind the wire to the left, and on the left side of the wire we see that the field is coming out. Now, so this is what this drawing is telling us. So let me repeat here. We have current going up. This current creates around that magnetic field. Right on this right side of the wire, right here, we have the magnetic field going into the page. On the left side of the wire, I have the magnetic field getting out of the page, okay? So being able to see this is going to be important for what is coming next. So be sure you understand that before you go to the next slide. Okay, now let's go here for the next slide. As we said, what we have it now is two wires, okay? So I'm going to draw here one wire that is carrying the current I1. And here I have another wire parallel to it carrying another current I2. Okay. This current I1 creates around it, all around it, a magnetic field. To the right side, so what is the direction of the magnetic field that it creates? Well, use the right hand rule, right? And we'll know that we have a magnetic field like this. Right? So this is the magnetic field B1. From what we discussed in the previous slide, I know that to the right side of this I1, to the right side of it, I have a magnetic field going into the page. Okay? Right here in front of the I1, well, it's going to the right. So right here in front of the I1, the field is going to the right. On the left side is coming out, but I don't care. What I care about is what is happening to the field on the right of the current, because on the right of the current is where the other wire is, and I want to know what is going to be the effect of I1 on the wire 2. Okay, so here we are now looking at the wire 2. So the wire 2 is carrying the current up. And now we see that we have this magnetic field into, the B1 from the current 1 is into the page. So field on a current creates a force. I want to know what is the direction of the force on this wire I2, that carries the current I2. So how do we get the direction of the force on the wire 2? Well, we are going to put our four fingers following the direction of the current I2, so pointing up. Where is the direction of the palm? The palm is into the page because that's where B1 is. So I get the thumb to the left. So I know that here on the wire I2, I have this force everywhere. This force, I'm going to call it the force 2, is the force on wire 2 caused by the field B1, caused by the wire 1. Okay, so this F2, this is the force, on I2, on the current I2, on the wire I2, caused by the current I1, caused by the field of the current I1, which is the B1. Okay, so what is going to be this force? This force, I'm going to use our equation for force. No? This force is going to be I2, because it's the force on that wire 2, on that current I2. So I2, the length of what? Of that wire I2, no? The wire 2, multiplied by the field. Which field? The field from current 1, the B1. Okay? And we could also think about the sine of theta, but the current and the field are perpendicular. Now I have the current going up and the field into the page, so they are perpendicular. I don't need to put the sign here. Okay, so very nice. I got the force on the wire 2. Let's talk a little bit more about this force. Well, we have then this force on wire 2 is I2, is the length of the wire 2, and then comes the magnetic field B1. What is the magnetic field? What is the equation for magnetic field? It's written here, right? The equation for B1 is that constant I1. I1 is the current on wire 1, no? I1. So I'm going to put all this here, constant I1, and then it's inversely proportional to the distance. Which distance? The distance of, of this wire 2 from the wire 1. That's the distance from the wire 1, which is causing the magnetic field. So here I'm going to put this D. D is this distance here between the two wires. Okay, so all that gave us this equation that you see here for the force 2. So the force 2, I'm going to rewrite it as you see in the slide. This force 2 is this constant here. So let me put this constant here. What else do we have? We have both currents. No? You see, both currents are showing up. So I1 and I2. What else do we have? This distance between the two wires. And then finally the length of what? Of the wire 2, because we are studying the force on the wire 2 caused by the magnetic field B1. Okay, now let's do the same exercise, but for the wire 1. Okay, so let's go. Let's put the wire I1, carrying the current I1, and we have here the wire carrying the current I2. What I want to find out now is what is the force on the wire I1. So I want to find out the force on the wire Y1 caused by the magnetic field from 2. Okay, again, let's use the right-hand rule to get the magnetic field, but now the magnetic field B2 caused by the current I2. Okay, so the magnetic field is this circle around the I2. So we have this is the B2. On the right side of the current, on the right side of the wire, this B2 is going into the page, but on the left side, it's coming out of the page. So right here, where the current I1 is, we have the B2 coming out of the page. Okay, so now what we are going to do, the second right-hand rule to try to find the force on wire I1. Okay, so how do we get this force? 4 fingers going up. Where is the palm? The palm is getting out of the page, no, because B2 is getting out of the page. So my thumb is to the right. So this means that the force here on I1, the force F1 is pointing to the right. Okay, and what is this force? What is this force? F1. This force F1 is the current I1, the length of that wire 1, and the field. Which field? The B2. Okay, the field caused by the wire 2. So this is the force on wire 1 caused by current 2. Okay, so this force F1 is the force on wire 1. So on current I1 caused by the wire 2, caused by the magnetic field created by this wire 2, which is the B2. Okay, again, we can write down what the B2 is. Let's do that as we did before, and you'll see we're going to find the same equation basically. So we'll have I1, L1. What is B2? The constant. B2 depends on the current I2 and the distance between the two wires. Okay, so we are going to find an equation that is very similar. Again, the constant I1 and I2, the two currents, the distance between them, but here we have the length of the wire 1 because this is the force on the wire 1. Okay, from this exercise we found the magnitude of this force very well. So this force depends on the two currents, the distance between them, and the length of each wire. F2 depends on the length of the wire 2. F1 depends on the length of the wire 1. What is an interesting thing that we found? Look, this force, what we found in this when we were playing with these two wires, we found that the force on wire 1 is to the right, caused by wire 2. We found that the force on wire 2 is to the left, caused by wire 1. So what do we see here? That when we have two parallel lines where the current go in the same direction, they attract each other. Okay, so two currents flowing in the same direction, two wires with currents flowing in the same direction, they attract each other. Very nice. What remains for you to check now is when you have two currents but parallel wires, but one is going up and the other one is going down, opposite directions, the forces are repulsive. Okay, so two wires where the currents are flowing in the same direction attract each other. If the currents are flowing in opposite direction, they repel each other. So I'm going to end this video now because it's getting too long. In the next video, we are going to do this one to prove, to demonstrate to ourselves, convince ourselves that when the two currents are opposite, the forces, the wires repel each other. So let's do this in the next video.